All right, we are live. Hi
Okay.
everyone, I'm really excited to host Maksim Markevich, CTO of Kreo Software. And if you're not aware about Kreo, you should definitely check it out right now. It's an amazing product. It's the first of its kind I have seen, like AI assisted construction software development. And I have attended Maxim's talk on Speckle Connect and AEC Tech, and he's an amazing guy. So you should definitely check out his blog and his talks. Thank you, Maxim, for being on the show.
Thank you, Maro. It's a pleasure for me to be here. Yeah, thank you very much. I appreciate it.
Yeah. So, Maxim, can you share some highlights of your professional journey till date? How you
Yes.
started from your undergrad till date?
Yeah, sure. So I was graduated from the university with ME in nuclear power plants construction. So after that, I was working as a structural engineer, actually. And so I was working on reinforced concrete structures and steel structures for different power plants. And at some point, I just started to do automation of my daily job routine, which carried actually me away a lot. So I just explain a little bit what does automation of my daily job routine means. So and actually the point was that I did a lot of reinforcement, right? So I used AutoCAD initially. It was back to those years. And so I just, it's a very, very, very routine process. You spend weeks on doing this reinforcement. And so at some point I created a lot of dynamic blocks in AutoCAD, and then I kind of figured out how to manage them with help of C# or VBA. And so I started to to create my first plugin. And the same actually happened in when I started to use Autodesk Revit. The same story. I created a lot of plugins, and actually some of those plugins, some companies here in Belarus, back to my country, they still use these plugins, which is really fun. So yeah, So after that, it has been a cool journey from structural engineer to CAD manager. So when I was working CAD manager, I was creating these plugins, right? Then I became kind of a BIM manager. And so in addition to creating plugins, I started to organize some processes in the company, like how structural engineers and architects can work together in Revit, right?
Mm-hmm.
So all this collaboration and all this stuff. And also was visiting a lot of conferences from Autodesk showing what I did automate and how it looks like and blah, 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 right? So and after that, I just met I became kind of a product manager. And when I met our current investor and CEO, and he just proposed me to do the same job I did, but he just suggested us to create a new products, to change a little bit the way how people work. And so I was really excited, and I started to do that. And finally, I became kind of co-founder and CTO of Kreo Software. So I really adore building design automation related riddles. What does it mean? It just means that you have a building concept, right? So any buildings which are repeatable and more or less the same, you can describe in some specific rules. And then it's like a riddle, right? So you need to find a way to automate this, and you need to find a way to make it happening in the minutes rather than days or weeks. And so I'm super excited about that. And so that's how it looks like. Yeah. So building design automation riddles, and I'm focused on providing the best software product to the AEC industry. Yeah, I'm trying to do the best, but
it's
yeah.
challenging, and
Yeah.
like that's incredible. Like you have so many different roles in this journey. And
Yeah.
I'm very curious to know, like, how did you prepare yourself for two roles specifically, like product development and CTO, because it requires a lot of technical knowledge and other things. So yeah.
Yeah. I'm as a person, I don't have any superpower, right? But I have a one skill well developed, and I really love to learn things. There is no a month in my life when I didn't learn something new, right? So I always I constantly learn new stuff. And I think in our current time, the world is changing every day, and people, they need to be kind of adjusted to this, and they need to learn things really, really, really fast. And so how was I preparing? My problem is that I cannot learn something theoretically. I always need to learn things through practice. So actually, when I started to work as a product manager, and actually the first algorithm in Kreo, the first service in Kreo was created by myself. And so actually I was working with my technical guys, with my software developers on creating software architecture. I was working on kind of integrating C++ algorithms into C sharps. We use .NET Core, and like it's basically my point is like you always need to do something not theoretically but practically. So you literally need to dive and to test it and to try it by yourself. And the more experiments you have, the faster you learn. And here is very, very important point. I cannot learn just by books. I need to learn on a real project. So when you see how this project makes a difference, and you know what problem you want to solve, it's just much easier to learn. And even if you didn't capture everything from the beginning, you will capture it step by step. And that's kind of, for me, that's the best way to learn. But I know that it doesn't work for all people. Yeah.
So I think I know answer of this question, and like based on your previous answer of how much you learning new things, do you believe in work-life balance?
No. I try. I mean, I'm 31 years old, and I just started to learn how to relax a little bit, to go for a walk, to have a little bit of fun. So my wife helps me a lot with this. She always requires me to do kind of some life stuff. So yeah, but it's not easy. Yeah.
So she is the one who comes late at night and snatches the laptop from your hands. Okay, it's time to go to bed.
So I have two, I would say I have two, life work balance coaches. This is my wife and my dog. So this, they actually make me learn a little bit about life. Yeah.
I see. So moving on, can you describe what is Kreo? What are the different products it offers?
Mm-hmm. Sure. Yeah. Kreo is, we have a portfolio of products, right? And sometimes it's quite difficult to describe all things we do, because we do quite a lot of different things. And we have a huge kind of history and story of our research and development. And I would say that basically we have two main directions. So the first direction is a quantification and cost estimation software, which is BIM takeoff to D takeoff, left one and the middle one, and also Kreo plan, which we hide from our website. We don't use it in the marketing right now. We work on this solution with quite a few clients, and yeah, so we don't want to make it here. And another direction is actually design configuration or building concepts automation software. So here you can see Kreo Modular, which is about this, and also we have quite a few bespoke customizations. And yeah, so yeah, that's how Kreo Modular look like. At least for now. We are already working on the version number 2.0, and hopefully in 2-3 months, you will see a new version of Kreo Modulars created specifically for architects. Yeah, so.
I see. And like, as a CTO, like, how do you manage your time between all these products, and like, how does a day in your life look like?
Okay, so it's a very hard question. That's a very old content. Yeah, we need to update it. So obviously I have products I love more than others. For example, I'm really passionate about design configuration and building concepts automation. And obviously, I have a team of nice engineers and nice product managers. So it's all about trust and sharing the same ideas and the same vision. And this is what helps me to kind of, I don't need to dive deeper in every corner of our team, because actually I have nice colleagues and they support me and they help me with everything. So yeah, it's all happened because of them actually. Yeah.
And like, can you like, if you take a step back, how was the initial ideas and brainstorming for this product? Like, can you walk us through that aspect?
Yeah. So initial idea was like, okay, guys, let's generate a building model in a 2 minutes. Okay, so let's say I was working for different companies, right? As a structural engineer, right? And I remember quite a few companies which were focused specifically on residential buildings. And to be honest with you, it was not just like any residential buildings. It was quite a specific reinforced concrete frame with columns, with a specific connections, with a specific reinforcement, some concepts about foundations. So there were a lot of rules, a lot of rules. And I didn't see a lot of diversity, to be honest with you. Yeah, buildings can look like really different because of facades, because of colors, because of something else, right? But at the end of the day, all these buildings they designed, they were following the same principles. And so the idea was simple, like if all these buildings, they follow the same principles, why don't we just automate the design of the building? So back to that times, I didn't know a lot about United Kingdom market, about United States market. So I didn't know like a lot of nuances, but the idea was like that. Okay, we want to generate a building in 2 minutes. That was the initial idea. Yeah, and so I just found a team who also was inspired about this idea, and we started to. And then when you want to generate the building, right? So you started to break down this building into different parts, not only from a BIM object standpoint of view, but also from a algorithmic standpoint of view. Let's say when you want to automate residential building, right? So you cannot start from a structural engineering, because floor plans and architectural part and functional zones are much more important, which means that you need to start from generating floor plan, and then you need to build columns, beams, and slabs on top of this floor plan. You need still to not crush this floor plan, right? So you cannot put a column in the middle of the room. But at the same time, you need to make sure that your structural frame will be efficient enough. And you will not have like, I don't know, 130 different types of columns, because you will struggle on the construction side. And so basically it has a lot of different sides. And when you start to actually gather all these sides together, you create what we call the building concept description. And when you have a building concept description, you try to we call it formalization, but actually it's creating requirements for mass algorithms. For example, the simple task, columns unification, right? So when you calculate it, let's say you have a building, right? And you calculated lots, and you did make combinations of lots. You launched finite element method, and you get all these actions inside lots, inside columns, and you did calculate all these columns, and you have 30 different cross sections, and then you need to unify them. And to make this unification, you need to explain to mass algorithm that actually unification, it means then when the difference in between this column and this one, 10% of volume, you can actually make this one as this one. And when the difference 10% of reinforcement, you can also make them equal. And this is how you do unification. And there are a lot of nuances, obviously, but yeah. So you break down big task into subtasks, you solve subtasks, and you gather them in one pipeline. Simple, right?
Uh, I'm just wondering, and I'm very curious to know your thoughts. Like, in order to have have that building configurator, there's
Mhm.
also like some assumptions and some like hierarchy you need to make. Like, let's say for architecture, structure, and construction.
Mhm.
Sometimes if you try to optimize structure, it doesn't work well with construction. So, like, how do you decide like what parameters weigh more and how to optimize?
Yeah, it actually very depends on for whom you are building configurator. Let's say when you build a configurator for general contractors who works in accordance with design build procurement road, you know the things which are the most important for them. For example, some of general contractors, they invested a lot of money in a formwork, in a specific formwork. And so, and they, to be honest with you, they don't care about structural efficiency at all. At all. They care about construction efficiency, and they care completely about different things. And obviously, this is why it's really challenging on the pre-construction phase, because architects and structural engineers and even MEP engineers, they all know that the same things, they can be done in a lot of different things, right? In a lot of different ways. And this is what makes it really hard, because you come with solution where you place columns in a certain way, and structural engineer can tell you, no, but I wanted to use a different scheme. I wanted to put walls here. I wanted to use beams in that direction. This is my window, blah, blah, blah. But actually, here, it's very important to not forget the main reason why we do that. Because the whole this activity, pre-construction, construction, it serves the only one purpose, is to deliver a building for
Mm-hmm.
people to live or for people to do something, right? It's not about having a lot of fun, about all possible structural schemes, etc., etc. It's about delivering a building. And so, and obviously, if you want to build a very scalable configurator and very flexible configurator, and even if you want to do that for one specific market, it's not easy, because you need to consider hundreds of different possible configurations, and it will take time. But this is why we really love working with the vertically integrated companies or with the general contractors, because by by their approaches, they reduce the amount of options and the amount of schemes, and so it
Mm-hmm.
makes the concept itself much easier to automate, right? So it's a hack, yeah, but yeah. So I didn't answer properly on your question, but the answer is it depends. Yeah.
but but let's say we take a end user, let's say architect or a developer,
Yeah.
then how do you deal with that use case? Like if you start optimizing for architectural use case, it like overall construction efficiency or structural efficiency, how do you encode that?
Yeah, it's a very good question. And I can tell you, we didn't solve this problem yet. We didn't build software which every architect likes. We didn't do that yet. And it's yeah, I cannot answer on this question because I don't know.
But if let's say you want to solve this problem and if you have time, like how would you approach this?
Hmm. So obviously, how would we approach? Can you repeat the question? I wanna
Yeah,
find proper answer. Yeah.
yeah. So let's say your end client is architects and you want to
Mhm.
build a configurator for them, which is optimizes their intent, but also you want to encode structural and construction efficiency in your configurator. Like how would you embed this and how would you approach this problem?
So I would right now, with my current experience, I wouldn't try to cover all this with algorithms. It's not about algorithms and it's not about technology. It's all about communication. To be honest with you, yeah, I know that this session is driven by technology and stuff like that, but it's not always about technology. And I would say, if we're talking about feasibility study, actually architects, let's say architects, they do their job like 20% of the time, and the rest 80% of the time they communicate. They communicate with a client, with a structural engineer, with a cost consultant, with a planning consultant, etc., etc. So if I would want to build a platform where architect, we can generate something for architect, and at the same time with respect to structural efficiency, I would create roles inside this platform, and I would allow these people to communicate in between each other and to kind of just to get like a feedback, immediate feedback. You as an architect generated something, you get feedback, you kind of correct something, you do some adjustments, you go further. So I think it's all about collaboration, this particular part.
Yeah. It makes a lot of sense. And
Yeah.
moving on to the AI part of Kreo, can you walk us through one of your product development?
Yeah, sure. So we want to talk about AI, right? Which is artificial intelligence. Mayor, I have a question to you. Does optimization algorithm, is optimization algorithm AI or not? Can you give me a definition of artificial intelligence? And then I will show you something.
Oh man, I'm put on the spot for this. Yeah, like for your previous question, like there are optimization algorithm from statistics which are non-AI based, which you can get, which gets the job done. And for my definition of AI is like, artificially, like predominantly, I think like my work and explorations are more on data-driven deep learning aspect. So I foresee like how you could extract intelligence from your data to solve a problem.
Yeah. Okay, it makes sense. Yeah, it makes sense. Okay, let me then show you probably something around computer vision. Okay, so we have a 2D takeoff product, which is mostly created for quantity surveyors and cost estimators. And so what these people do, they upload 2D PDF drawings, and they try to extract quantities out of those drawings. So when we obviously our journey, we started with a Kreo plan, which is a product which do it with BIM models. But to be honest with you, like BIM models are not quite there. I mean, and the industry is not quite there. And this is why we built 2D takeoff. So our journey was really fun. We started with a Kreo plan, which is like a smart scheduling 4D simulation software, which works on the BIM models. And then we realized that there are no BIM models with required quality. Then we built a BIM takeoff, which we just simply created for the quantities, extracting quantities from a BIM models. It was much better than the Kreo plan. I mean, from a market acceptance, right? But still, we just realized, okay, people work with 2D drawings, and this is why we built a 2D takeoff product. So let me probably show you what stuff we do there. Okay, so I'm gonna share my screen. Can you see that?
Yep.
Okay, cool. So it's our 2D takeoff product. As I told you, we had Kreo plan, 3D takeoff, and 2D takeoff. Sometimes I have a joke that it's our degradation way. So because we started from here and we ended up here. But anyway, so I'm gonna create a project, and I'm just gonna update upload PDF floor plan. Okay, let's say this one. So it works on any residential floor plans. So I'm gonna create a project, and here we go. So obviously, yeah, we uploaded PDF. So this is how it looks like. Okay. So then what we need to do, we need to scale this PDF. At some point we did it automatically, but then actually, so we found the way how to do it automatically, but it worked only in a 70% of percentages of cases. This is a good example how technology was crushed about the market. So it worked in a 70% of cases, but the problem was that people stopped validating it. And
Mm.
in the rest 30% of cases, they go further with the wrong scale because
Uh,
because because they relied on machine learning, on recognition, and on other stuff. And this is why I'm a big fan. And we, on our experience, we understood that it's not only about technology, it's also about how you cook a specific technology, right? So if you want to put a
mhm.
lot of automation, be ready to put a lot of notifications, validations, and other mechanisms which will allow you user to not create mistakes, right? So let's say we
Mhm.
want to do, let's say it's our 1 to 100 scale. I'll apply it. So and then I'm going to launch auto measure. So it's here, this button. So what's happening right now here, I'll explain a little bit in details, but basically we try to read this PDF. And again, I can even show a little bit under the hood. Obviously, that's not the last version. And we changed it already probably 15 times. And but here some explanations how it works. But probably it works to show you first of all how it actually works, and then I will explain a little bit how did we do that. Okay,
Mhm.
so we're still waiting. It's not a big PDF plan, but it can take like a 20-30 seconds. Yeah, it's actually done. Let's go a little bit here. So we have a plan, right? And this result, they came from auto measure. And let me, you see here, 103
Mhm.
polygons, they came from auto measure function. And if I expand it, I will be able to go through all of them and to see what did we define, okay? So
Mhm.
obviously, just to double check, so Windows, this is Windows we found here. So basically you can go and you can see, probably I need to do less opacity so we can see it better. So this is Windows we found. This is openings. It's actually doors, but because it's not, you see, it's just because it doesn't have like a proper
Mhm.
door visual. That's why it's opening for us. Then we can see actual doors. So, I mean, all this stuff is defined fully automatically. And actually, I can say, even, okay, this is my external doors, and this is my internal doors. Then we have bedrooms. Okay, we have hall, which is hall in each apartment, right? So we have a living rooms,
Mhm.
um, cupboards. We have even cupboards. Yeah, we have
That's
corridor,
awesome.
which is like this one, elevator, which is like this one, uh, some balconies that we define. Nah, you see, that's a huge mistake, guys. It's not balcony, it's a
Mhm.
legend. So basically, obviously, we do have mistakes, and this is a place where user should adjust it. For example, I can easily remove this, or I can move it to the proper category. Because here also we have undefined, and which is this one. And for example, it's my undefined, and I know that this is being stored or something, and I can simply move this measurement to any different folder, and then we will use this data to retrain our algorithm. So it's kind of, and again, it's not only about building the proper recognition, it's also about building pipeline which allow you to retrain your algorithm and to populate your data set. So, and obviously when we got all this data, we can group this data, for example, in flux. But again, there are some obviously inaccuracies, right? And
Mhm.
the point here that you can always change it. So if you want to adjust something, you can just press modify. You can go and, for example, remove this point. Like you just remove this point, and let's say you want to move this one, you can move it, or you can add additional points. So you can do a lot of adjustments, right? So it's not a big deal. So it's relatively easy. Uh, but the point is that like that's not the results of ML algorithm. That's already results of post processing. So when we did the results of ML algorithm, they look like a pixel-wise stuff, right? And so then we adjust them and we make them looks good as a measurement. But at the end of the day, it's not about one algorithm which does all work. It's about the whole pipeline of different things launched in a specific sequenced way. Okay, so and obviously here we group it into GEA, gross internal area, gross external area, net internal area, and also we define walls. For example, here you can see all these walls. Yeah, so that's the place where we, for example, used machine learning. We have right now data set of different floor plans. It's residential buildings. It's around 20,000 examples, and we do update it every week. So like a few months ago, it was much less. And right now, the more customers we get, the more often we update it, and the more faster we grow from a data set standpoint of view. But again, it's a technological point of view. From a user standpoint of view, it's still not perfect. I mean, it's not perfect at all, right? So because you need to, even when you don't draw this stuff, you still need to go through each element and validate it. And sometimes some elements is much harder to validate rather than to create from the beginning, from the scratch, right? And this is why, again, I'm returning back to the topic. It's very important how you cook the technology. It's not only about the technology itself. So you need to deliver it in a very specific way. And this is a huge sphere of user experience, user interface, product development. We don't talk about it today, right? So we talk today about technical stuff. So I can give you a few insights. Again, it's just a few versions. Like, how did we do that? So basically, we input PDF, right? We got different drawings. So then we do what we call segmentation. Here again, I cannot share with you kind of nuances and the details, but I can tell you that we used initially convolutional neural networks. Then we started to use transformers, and finally we chose one of the popular transformers. I will not name it, but we did it. So basically what it does, it just gives you different masks for walls, masks for windows, doors, and you kind of build a final mask. It looks like a piece of shit, to be honest with you. Yeah, and this is the exact place where we needed to build what we called post-processing, because you know, at the end of the day you have stuff like that. So it's just like a very, very vague boundaries, and you need to get something like that. And so here, first of all, we convert it into the results into vector graphics, and then we do kind of alignment. And again, to make it work perfectly, we need to build adjacencies. We need to understand which rooms belong to which apartment connect with corridor, etc., etc. So we build adjacency graph. Then we kind of double check ourselves with doors, with internal doors, with external doors. Then we kind of choose external, internal walls. And then we do classification. Again, we just say, okay, find this space is this room is this one. And finally, we do validation. And we do this validation. It's where the users do this validation, or our labelers. Do you know who you are, right? So we have a guys, and actually they behind the scenes, and they do all this job. They kind of validate the results, and they create a data set for the next retraining. So the stuff I showed you for the small team of, let's say, 3 employees, it took like almost 1 year to actually roll it out to the production phase. It seems very easy, but actually to roll it out to the production phase and to show it, when you start to show it to the people, it takes time, you know. Yeah. And then we started obviously speculating on this, and we started to think, okay, what if we, because when you, and the results you get, obviously they not 100% accurate, right? But the point, and here exact place where we merge two direction, because the first direction is like this recognition 2D, right? And the second direction, our building concepts automation. And our idea was, okay, if we have 80% correct results, and if we apply 3D model concept on top of them, will it work? So that was our question like 10 months ago. And we tried, and we did one project where we literally converted PDF plans into 3D model. I mean, it's not working 100%, right? But it's just we are talking right now about a lot of research, and kind of technologies I show you, they not all in the production phase. They're not all used by users, because we are a company and we spend a lot of time and resources on research, you know. Okay, it was a long speech. Sorry for that. You asked me to show you.
No, it was very helpful to understand the whole, like, how it works and like the whole algorithm. And I have a few follow-up questions. So the way I understand is you have that in Transformer, you got your PDF and then you converted into raster data. Then you had different mask of classification of different like room types, door types. Then you did like prediction, validation. So I'm curious to know, like, how did you handle the aspect of scaling and normalizing across different plans?
Across different what? Across different plans, right?
Yeah.
That's, again, it's a tricky question. It's a good one. Yeah, and obviously you don't train your machine on the whole plan. You train your machine on small pieces of it. So you train your machine on segment of wall, on window, on door, on space, right? So you don't care about overall picture. And this is what we leave for our post-processing, because in the initial step for us is crucial to understand small pieces. And then we use some heuristics and some post-processing analysis, which help us to assemble the small pieces in the holistic picture. You understand what I'm talking about, right? So yeah, that's if I answer this question in a simple words. Obviously, there are also some nuances, and I cannot share them with you.
No, that's totally fine. Like, first of all, I must admit, like, I have seen people doing like in the research community training models on like Colab, but it's a whole different game of like scaling it in profession. And like I love the fact that you have that user interface where you could manipulate the prediction. It's very easy to do that, and also like continuous training aspect where you are continuously upgrading. So that architecture is also very
that's, I here I would add, there is a big gap in between showcasing something or creating a research paper and in between delivering this something to the end users. Let's say it's like the biggest gap in this, it's like, because I can tell you probably 10 or 5% of our R&D goes to the production. The rest is just like, usually it just dies. And actually everybody who is working on research and development, especially people, probably your community, your audience, they should know about that it's okay. It's okay to fail. It's okay to not deliver to the final result. People just need to have a lot of fun and, just have fun and build fun stuff. And then at the end of the day, you will build something which will be great. So but it's very important to keep in mind that the delivery itself is the most important part. Because, you can showcase a nice technology on one example, but okay, publish it, show it to people.
Yeah. And that's when you get it out in the public and when they start experimenting on new examples where your validation test and what's your failure
Yeah,
prediction rate, you get to know. Yeah.
yeah, exactly. I remember when we just launched it, there were quite a few people who came to us and just like, it's a shit, it doesn't work at all. Yeah, and we were fixing it on a run, and so yeah, it's still fun. Yeah.
Yeah. And I'm curious to know, like, also getting the output prediction from, let's say, raster to from the look, it looked like you're getting again in like post-processing in raster to vector form for various building elements. So that's also a challenge, I guess. Like it's not simple.
It's like this is not machine learning, right?
Yeah.
It's just
Mhm.
like that's what we were talking about. There is a part which machine learning does, which is which depends from a data set, etc., etc. And then for this part, we use, for example, dynamic programming. You probably heard about such things like OR tools from Google. And so it's a dynamic programming algorithms. And so we use them to fine tune our ML results. And that's, I can tell you sometimes this part, it's even much harder than ML itself. So, because you need to, it's like, it's actually the building the bridge in between real world and the pixel world.
Yeah.
Yeah. So that's very difficult part. Yeah.
Yeah. I haven't like read much about that OR from Google. But one of the study I was doing is there are like rule-based algorithm where
Mm-hmm.
based on the pixel, like uh, they can normalize the vector line and like find what's the
Yeah.
right fit. So is it on the same line? Like if you can elaborate on.
Yeah, it's kind of it's the same intent, right? The same intent, and actually, yeah, it's not necessary to use exactly dynamic programming algorithms. You can use different as a different ways. But to be honest, like when you solve such a problems, it's always question of how much time would it require. And obviously, some problems can be solved by some specific algorithms in a 60 minutes, let's say, right? But you cannot use this. You cannot because it's not acceptable for your product. So we are very careful about this. And our mathematicians, like, because we have a nice mathematicians in the Kreo, and they usually do prototyping in a Python or they do prototyping with some famous algorithms. But when we go into production, we usually create C++, we usually use very fast algorithms, and we usually use some heuristics which allow us to, just to work in acceptable way, because you cannot make people wait like 20 minutes. Yeah.
Yeah. And like if you can talk a bit about the implementation aspect. So if
Mhm.
this is what my first impression is, like you did like data set labeling, then training of either on the local GPU or on cloud, and
Cloud.
then the
Yeah.
yeah, on the inference side you have this website, and like from my knowledge, like people use like Docker and implementation of like either AWS or Google's cloud
Mhm.
to for the inference part. And is it the way, or yeah?
Yes, it's the way. We use AWS. We train our data set on GPU servers from AWS, and then we kind of save the weights in a kind of a table, and we use it in a Docker for the users. Yeah, and obviously then when we gather like a few hundreds PDFs, we do validate them, we update our data set, and we do the same thing again. Yeah, it's a way, and this is how it usually works. Yeah.
I
So
see. And I'm curious to know your thoughts on like what's the role of AI AC enthusiasts because like the way I see, like it's way difficult for us to develop a whole new architecture or a whole new model from training. So are we more like a fine tuning guys, or are we adding our domain expertise for data set curation? Like what's our role?
The,
Where is our value?
um, the value in defining opportunities. It's a huge value. It's like, let's say, to get the first sign about, okay, it can work, you need to do some small step, right? So you need to do some first step. You need to validate something, right? And actually, AEC enthusiasts who is working on it, they maybe they publish it, maybe they share their results in between each other. This is how actually this common brain works, right? So it all goes to companies like Kreo. It all goes because we have the same structure. We're very open minds. We share a lot of insights. In outside, we talk to different people, and these different people, they share their insights with us. In that case, we are very open. Again, we really believe that openness is the way for development, and kind of closeness is the way to degradation. And this is what I like about IT industry. You can find a lot of useful things just as an open source, right? I'm not saying that people, like, we do business, right? So we deliver products, we sell products. Obviously, we cannot share them because it's our IP, and this is how we earn money, right? But there are a lot of things, like you're saying, models, data sets, some validations, which can be shared in the community, even across companies and enthusiasts. And this is the way how the industry can go faster from a technological standpoint of view. But again, technology is just one leg of industry.
Yeah.
There is another leg, at least one. Yeah. So AC, and I what I do, my Saturday usually look like I go through Twitter or LinkedIn. I see some cool paper from guys who do their own research. I go through them, I read them. I really enjoy that, and this is it brings a lot of inspiration. It's not like, as I told you before, we don't build stuff in vacuum. We need to see community. We need to see, how quickly this even convolutional neural networks or transformers evolve. Like 3 years ago, I mean, they just didn't exist, like.
Yeah.
And then just models better and better, and you need to improve. You need to be on the edge of everything. So it's, yeah. So I think IAC enthusiasts, they will move technological part of the industry for sure. Yeah.
Yeah, and it's also very difficult to keep up to the trend of the research going on in AI community, because like every day there are new papers, like multiple papers every day being published.
Yeah, exactly. And this is why it's really cool to have R&D department, just the people who have fun and just try some things, because I'm out of this already. I know how it's done, but I mean, I'm not doing that anymore. Yeah. And I even don't understand most of these things. I mean, what my guys, what our employees are doing. I mean, because there are just a lot of them. Yeah.
Are you guys open for like, if any university or academic researchers wants to collaborate on some AI part?
Yes, and we do that. For example, we were working with university from Belarus. This is a place where our biggest our office, actually, the whole our R&D office is in Belarus, and our main office is in London here. And actually, we were working with a university from Belarus on some things. Yeah. So, and we are open to this. Yeah.
I see. And like our industry is not that being open for data sharing and open source development.
I know, man. Do you know how many NDAs I did sign off the last week?
Oh my God.
I do sign NDA every day, and sometimes people ask, "Can you sign NDA?" I say, "Yes, sure." I sign NDA, and they send me a fucking floor plan. Like there is nothing. Like literally, it's a really bad floor plan. But I signed off NDA to get this floor plan, and I just like, what the hell is going on?
Yeah, like it's yeah, I was talking to like Clifton the other day. Like the IP is like people think that grasshopper scripts is their IP, like it's, but if you don't capitalize your data, it's nothing. Like there are a lot of construction data, but if it's just sitting in your server and you think it's your IP, it's you're not using the value out of it.
Yeah, that's correct. But I can tell you when we sign off kind of enterprise deals, when we do bespoke customizations for companies, we work hard to separate our IP from theirs. To be honest with you, again, it's not because we want to do that. It's because that we don't have any other way.
Yeah.
Yeah.
And it's also a difficult conversation, like to begin with, when you are getting new companies on board. So
Yeah, that's correct. Yeah.
yeah.
I have a
And
question here.
yeah, go ahead.
Yeah, so like it was really cool to hear you and your thoughts. Now the question comes, like when we are trying to start a product, I don't know like how it started with your case, but we never try to limit our expectation that we'll try to hit certain market or something. It's very hard to select that one thing. And I saw your determination that no, we were very sure that you want to not go for architects, but we will go to certain market. So what will be your key drivers that we should look towards for
When
selecting
you
that?
Okay, so when you want to launch a product, like a specific product, right? Okay, so again, in my understanding, there are three types of products. Okay, let's say there are three types of three different approaches of creating products. One is technology driven, is when you build something and then you started to figure out what can we get out of it, right? This is the first approach. The second one is competitive driven. So you know some market and you know some software. Let's say to take off, right? So Bluebeam, Costex, PlanSwift, blah blah blah, and you just go, you do research, you understand what needs to be done, you deliver stuff, you try to compete. The third approach is user driven, and this is what I prefer. I mean, to be honest, I didn't do it from the beginning, and we didn't do it from the beginning. We learned a lot through the past 4 or 5 years because we failed with a lot of products. And right now, our approach is very simple. When you want to build a product, you need to clearly understand the problem you are building product for. And also, I have on a joke, you need to be able to close your eyes and to imagine your user solving the problem. You should be able to imagine how they do it right now, and you should be able to imagine how they will do it with your product. And if you cannot imagine your user, or you cannot clearly name a few of your potential users, that means that your product doesn't have any users. This is very crucial. It's like we found a fine inside my team. We find a cool kind of analogy, because when you build a factory, you already know who you're gonna sell the products factory will produce. You don't build a factory with uncertainty. Like, okay, you build a factory which will produce something. I mean, you always know what you're gonna produce and whom you're gonna sell it. And so which problem these products will solve for these users. That's, from my point of view, that's crucial. And again, let's say you define the problem, you define the user, then you need to understand how do you want to scale, what market size you want to see, and then you already can go and define market size. You can start from a top-down approach, but then you will end up with a bottom-up approach. So, and you will kind of prove for yourself the size of the market. And if you will see, okay, market is not big enough, with this disruptive price, we will not survive, you will go and validate, you will go and reconsider, you will go and repeat again. I mean, it's a very iterative process. It's like, yeah, but in my head, everything starts from a problem space, then it goes to solution space, market, value chain. It's also very important to understand, do you fit in a current value chain or do you disrupt the value chain? Because when you disrupt the value chain, it's a completely different go-to-market, it's a completely different business model, it's a completely different financials and et cetera, et cetera. It's just like, you just need to go through all these steps. Yeah, I wrote a fun blog about mutated Pythagoras tree framework. It's just like, there is nothing really new. It's just things about how to build a product gathered together in some fun story. Yeah, so it's a cool question. Yeah, it took me 5 years to understand anything. Go ahead.
So like Kreo, like as a Kreo when started, was it very clear that this is the only market we're gonna target?
No. No. We started in a way, okay, guys, let's build some cool technology. And we built some cool technology. We spent like 2 or 3 years. And then we started to sell this cool technology. And we realized no one needs this cool technology. And we just like, oh, fuck. Yeah, that's what happened. That it was a good lesson. And actually, that's where we, as a company, I would say, we built a lot of technological advance, and some things we built like 2-3 years ago, we're still figuring out how to monetize them, how to deliver them as a product, and et cetera, et cetera. So it's still the way how we went through all of this. It still make a lot of sense if you survived, but the problem is you might die, right? Along this way. So, because right now I see a lot of potential benefits. For example, we built our own 3D visualization engine, and so we had resources for that, and we built it. And at some point, I was thinking, oh, we just reinvented bicycle, or we reinvented the wheel, right? But right now, when we have capabilities to build the vertical solutions on top of our own engine, it's very great, because whatever you need, you just go and add it, and it's kind of cool. But again, when you plan such an activities, you need to make sure that you will have enough resources and money to deliver that, right? So it's yeah, but it's a long topic. Yeah.
Yeah, and I think like that's a good segue to like few of the blog articles I wanted to touch. So like definitely like there are some amazing articles on this blog, so I highly recommend viewers to check that out. So one article which I found quite interesting is in this one you different like talked about building design software, automation software, and configuration software in clearly distinguished. So can you like elaborate on like what goes into a recipe to build a configuration software? You mentioned like there are different algorithms you use, but if you can elaborate on the implementation and development side.
You mean, yeah, okay. So building configuration software is actually like, actually people can build this software using building automation software, right? But building configuration software is a software which has a specific user interface and a specific business logic. And what's more important, it can be scalable for different people, for different industries. Because when people, we all know when people use Grasshopper or when people use Dynamo and they build some cool pipelines of algorithms inside the company, they change them each time inside the company. And I don't know any one case when something out of the company came and became a product for the, let's say, external use. And this is Yeah, and this is I mean, it's not bad. It's just how it's set up, right? So building design automation software makes a lot of sense for me. I know, for example, yeah, guys build the fun stuff with Hyper. You probably know Hyper, right? So they kind of yeah, I like what they do, but my point is like there always will be architects who will use it. Very advanced, half architect, half coder, half, I don't know, wolf, half human, you know, this kind of thing. Yeah, but I also know a lot of architects who can sit and create a nice building concept, and who can leverage this building concept to someone to automate it. And it also can have a lot of benefits, and not all architects should go and learn programming, right? Some of them should go and learn, I don't know, knowledge management, should go and understand how to define the common things inside the buildings, how to make it scalable, how to build a nice concept, right? I'm just saying that it's just a different tools for different purposes. Yeah. And the point in this blog was because I don't think people, when I went through G2 Crowd and Capterra, I didn't find that people actually separate building design configuration software a lot. And I realized that it's something which is, you know, like as you see here, it's a CAD software, right? So building design, BIM software, CAD software, sketching software, and 3D modeling software, and all this stuff. And actually, I think that there are a lot of configurators occurred for the past, let's say, 5 years. ArchiStar, SpaceMaker, TestFit, Blueform, a lot of them, and they continue to occur. And we also Kreo Modular, and you know, and I mean, I know at least 15 similar products. Just don't want to name them.
Yeah.
Yeah. So, and I think it's actually something which is changing in the industry, and that fact that Autodesk bought SpaceMaker, it's also a big sign, which means that it's literally a new software category occur right now. You know what I'm talking about, right? So people started to do this kind of automation, and yeah, that's the point of this blog, just to kind of to say, okay, guys, your classification is shitty. This my is the best one. I'm joking. Of course, it's not. But I was trying to
yeah.
Yeah.
So, like, one of the thing I was thinking is a lot of times when people could develop a good product idea in building automation software when in their Grasshopper script or Dynamo script, and how do we translate like that business logic into prototype and maybe starting their own startup? Like, what's your piece of advice?
Yeah, I think actually this is the best way to start a startup in the AC industry, is to use something which already exists, right? So you don't need to think about backend. You don't need to think about infrastructure. You don't need to think about how you're gonna balance your servers, right? So you don't need to think about architecture of your platform. Will it be distributed or monolithic or microservices or whatever? It's all unnecessary things when you validate your idea. You can create a script in a Grasshopper, and that's enough to start talking to different people. Let's say you created something for architects. You created script. Just create a video, add some maybe prototyping. I mean, everybody can go on Figma, for example, and create prototype. I mean, I do it almost every day. And I'm not designer, I'm not UX UI designer, but when I want to explain idea to my team, product idea, I go in Figma and I create prototype. It's a very shitty prototype. I can show you later, but I mean, but it's still, it's just explains.
You can communicate. Yeah.
Yeah, you can communicate literally. So you have a Grasshopper, you have a shitty prototype, you go to your customers, you talk to them. Write to people, LinkedIn, Sales Navigator, whatever. Write to people, ask them about interview. show your, but again, you shouldn't talk from a solution standpoint of view. You should talk from a problem standpoint of view. You need to confirm that, yes, they have this problem. Then you need to confirm for yourself that somehow they solve this problem right now. And this somehow is a really bad way, is a really bad, annoying way. And your solution will be a nice solution for this problem, right? And so when you found enough proof, that means you have idea, you have some drafts of this idea, you have prototype, you go further, you go build your product, right? You go find money, you go build your product. That's probably, yeah.
Yeah, and like one of the challenges I see is we hear a lot of stories about AEC startups failure or big funded startup failure. So apart from like discovering or finding a good product, like the business aspect is also challenging, how to find the right finance model.
Yeah, it's very challenging. And also everybody talks about that IEC industry is very difficult and very, and I know a lot of people who says that AEC industry is a kind of specific industry with a specific set people, set grumpy people, etc., etc. I don't believe in it. I mean, AEC industry is the same as any other industry. The problem is, like, again, if we will think about delivering building as a whole way, as a whole way of delivering building, it's much more complicated than delivering a photo or video or car or something else, right? It's very contextual industry, and this is why it's very difficult to automate. There are multi roles, multi stages, different procurement roads, different planning stages. I mean, it's just very complex one, and this is why it's hard to build a nice product in there. And if you will have a look into companies, let's say what I do quite often, I go to Crunchbase and I always kind of follow the best, let's say the best companies in AEC industry. And actually, the most of them, it took like 6 years to build a product which actually started to be successful. Okay, I don't like this word, like to be successful. It doesn't make any sense. The success is a very vague definition, right? But the point is, like, it's not quick. And in the AEC industry, it's relatively difficult to find examples when someone built something in 1 year and became like unicorn or something like that. It's not it's not the case, right? Because again, from a very fresh product, so you probably know this Hopin platform, right?
Yeah.
Hopin platform. They are very famous right now, and they just built it in a couple of years. I don't think it's a case for AEC industry, to be honest with you. Yeah, when you go to Bluebeam, PlanSwift, Autodesk, it's just like these companies, they spend 20 years. But I'm not saying that it will be the same in the future. I'm saying it will change. But it's not like you can build. I hate these phrases like "let's build Uber for construction" or "let's build TikTok for construction." Let's build Instagram for AEC.
Figma for BIM.
Yeah, it's a bullshit. It's like how you can go and build Uber for construction if Uber contains 2 roles and construction contains 55 roles? How are you gonna go and build Uber for construction? I don't understand that. It's like it's a very I hate these phrases.
That's a good point. Out of like totally random question, like what are your thoughts on blockchain or metaverse or other domains?
Oh, metaverse. Like, do you want to hear just an opinion or some relation to our industry or whatever?
Like your honest opinion on this.
I think that again, metaverse idea is not new, right? So it's all about games. There are a lot of platforms who already did it. What's happening right now is just a marketing hype around it. So I mean, and that's cool idea. I'm playing computer games. I mean, I think it's a good idea, and it can grow in something big for completely different needs, for completely different purposes, right? Some of metaverses, let's say, can be very useful for people, right? And who knows? And so I don't have any negative kind of thoughts on it. For me, it's just a technology, and right now it's just Facebook has launched this marketing campaign, and everybody talks about it. And yeah, I'm just I don't really like. I'm really focused on IC, and I wouldn't say that I'm really kind of like read about all technologies in, you know, in everywhere. I'm a AC guy, so I don't know. Yeah.
Yeah. And if you had like more time or resources, is there another idea you wish you could work?
Yeah, there are a lot of ideas. I mean,
On your problem.
ideas. So you want me to name a few of them, right?
Yeah, like couple. Yeah.
Yeah. Okay.
Unless you think
So,
it's gonna be next big thing and you wanna hide it
no, I
and
mean,
like disclose.
I can expand on some of them, but again, it's not. I mean, if I will share them, nothing really will change because they're very complex. You know, for example, you know, beam object, right? Beam object idea, like manufacturers and material suppliers share their objects, and through beam objects they being implemented into Revit, architects uses in a real projects, and then it's kind of warranty that these objects will be bought by general contractor from these manufacturers, right? So I like this value chain, but I think about bigger scale. Let's say when you have not the objects separated like window or door, but when you have the whole building concepts, right? So when because there are a lot of vertically integrated companies occur, and I like this trend. I like this trend because it's kind of it's attempt to reduce the complexity of industry and to allow it to be focused more on the real things, on delivering buildings for people to live, right? So it's how I see it. And so in my understanding, if it will be kind of a marketplace with a different building concepts, which will be related to different geographical regions, to different manufacturers, it would be really amazing. Like it's just, again, but it's just a one idea, very simple, stupid one, but that's how I see it. It could be really great. Yeah.
I see. And I'll wrap up the interview with some light questions. So let's do a rapid fire round, and you have like only 10 seconds to answer it, and you gotta keep it short.
Oh.
Okay. So my
That's a
first
problem.
question.
Yeah.
My first question is like, which city is in your travel bucket list?
Sorry, say again.
Which city is in your travel bucket list?
Tempe, Arizona.
Interesting. Any book which made a big impact in your life?
Atomic Habits, Skin in the Game. Yeah, that's two.
And which city is your favorite in terms of architecture and culture?
Oh, okay, London.
I see.
I know nothing about architecture, so yeah, London. Yeah.
Okay. Then I have a structural question. Who is your role model in structures?
What do you mean?
Like your structural engineer who you look up to?
Yeah, they all from USSR. So from my university, there are some, you know, it's just like, yeah. You mean exactly structural engineer, right? Or
Yeah.
okay. I cannot answer.
No, it's fine. Like if if
I
there is
cannot.
a, like
I never think about that.
it's okay.
It's a very hard question. Yeah.
I see.
Can I skip
And
it?
I can broaden it up to any engineer instead of structures, but
That's more hard.
That's because I see my problem. I never thought about this in a way that I should remember someone who did something. You know, I never remembered any architects. I cannot name you like any, even for famous buildings who was the architect. I just don't keep this information. Sorry.
yeah, you could always Google it. So
Yeah.
And what is one thing which most of the people don't know about you, but they'll be surprised to know?
Okay, so I do quite a lot of jiu-jitsu. So I practice jiu-jitsu already 6 years. So I really do it like 4 or 5 times a week. Yeah.
That's cool. And what are your hobbies? I think partly you might have answered it. Yeah.
Yeah. So I would say that I really love jiu-jitsu, and also there is one hobby. I really love to assemble furniture.
Oh.
I don't know, and my big dream is to build my own house by my own hands. Yeah, that's a very stupid dream, but it is. Yeah.
So you have opinion about IKEA configurator?
Yeah, I like IKEA. I think actually that yeah, I like IKEA. Yeah.
I see. And lastly, is there anything which we didn't cover in this interview, but you like to share?
Yeah, we actually covered only a small technical part I wanted to share, but it's okay. Yeah, maybe we'll somehow discuss it. No, but I think we covered a wide range of different topics, which is really cool. I mean, yeah, it was a good interview. Yeah, I think so.
Yeah. Like we can like spend more time if you want to cover the technical aspect, because like I'm very flexible.
So
Yeah.
am I.
Okay. Okay. Yeah, I can tell about one another problem we were solving, and let me think what I want to show. Yeah, I can quickly cover the classification problem we solved with our Kreo plan solution. So as you remember, Kreo plan is a solution for producing cost estimation and scheduling for BIM models. So what you do, you just upload your BIM model, we read it, and then we build cost estimation, we define sequencing, and we build Gantt chart and 4D simulation. Let me just show you probably a few. Yep, hold on a sec. So you will understand how it looked like. Okay, let's say we uploaded a project, right? And then we need to do validation of the project. And actually the first step of this validation is like, it's necessary to classify all elements. And so what we do here, and as you know, all these elements which came from a BIM model, they probably have a specific information, a specific parameters, right? So, and quite often this list of parameters are not full, and there is insufficient information about the elements. And so what we do at the first step, we classify these elements. So basically we try to predict the class of the element by insufficient amount of information, okay? For example, when we're talking about walls, if I open this, for example, wall, usually it came in the software in the way like unclassified, like you see here, right? For example, there were no information about material, there were no information about layers inside the wall, and also there were no information about that this is a wall, because as you know in Revit you can create the same, you can create wall as a generic object, right? So you will not even use a wall family or something like that. You will create generic object, and we still need to predict that this is a wall, because it affects how we will do sequencing and stuff like that. And so we, again, that's right now I'm showing you the way how you already kind of validate the results manually. For example, when you can say, okay, this is my concrete, this is in situ, this is heavyweight, and as you see, the uniclass is defined. So basically, we use uniclass. Do you know what does uniclass mean?
No, I am not aware.
It's a classification system which contains system and product, and as you see here, SS 2511 blah blah blah. This is system, this is product. So basically, it doesn't matter whether this uniclass or something. We use just this as a basement for our further predictions. And so what's basically happening here is that we try to predict all elements and to understand who are they and how they look like and what kind of, so you see it's like all these types we classify. That's where we spend a lot of time building what we call classificator. And again, here we used, you probably know BERT, right?
Yep.
ML algorithm, which actually help us to predict additional text properties of the element. And then we use our ontology tree we built inside our company, and it also took us like 1.5 years. And so with help of the BERT and ontology, we predict the class of the element. And actually then with this classification, we can go and do activity assignment. Here we need to choose database. And on this step, what we do, because we know classification of elements, and it basically means that now we can assign specific activity to the element from the database, right? And so it takes a little bit of time. So as we did, let's just wait. I just want to show you how the final 3D schedule look like, and just to explain for you that it took like probably more than 20 separate algorithms to make it all work together. Whoa. So let's say we find with activity assignment, then we go to measurements. Again, it's a similar step. So here you just apply the method of construction and method of measurement to the element. Because, you know, if it's a round column, you need to measure diameter. If it's a rectangular column, you need to measure width and height. Okay. So, and yeah, and then when it's done, you have access to all the steps, and I will show you only one. For example, for the hour schedule, it just basically shows how the building is being built. So, yep. So here we go. It just shows. Here you can see resources. Here you can see activities, what's going on right now. And you didn't input anything. You just uploaded your BIM model, and then we predicted and we built our own sequences. And we just connected it with your database. And so we show you how the model is being generated. Yeah. So but the key step was classification. And this is another place which we kind of created something connected with machine learning and rolled it out to the production. Yeah. So just an example of another ML production story.
Man, I love this product. You should have shown this earlier. This is such a cool product. Yeah.
Yeah, I mean, yeah, we have some in pockets.
Yeah, you were
That's
like,
actually, yeah, but again, that's product which we built a nice technological product, and then it was relatively hard to sell it because it takes like a different roles: quantity surveyor, cost estimator, bid planner, uh, like all these guys, and they need to work in the one platform, and they actually don't work together. They use Excel spreadsheets or separate software where they input their sequencing manually and blah blah blah. And so to implement such a product in a big company, it can take like 1 year or 1.5 years because they need to understand all nuances. They need to build their own database. They need to teach people how to use it. So it's a very big story. It's not like a product which one person can use. And this is yeah, that's kind of what's called innovation.
yeah, I loved it. And I'm assuming like there is also like a feature where you could change the schedule based on like real time construction and manipulate.
Nah, we didn't build it, but actually it's logical one. When we build this product, we assume that it will be for pre-construction phase. And obviously, if we will continue development or if we will want to make this product available for the construction phase, then we will need to add functionality where people will be able to compare kind of a plant versus real one, maybe to mark some specific places, to say, okay, here we stuck and we cannot go further, etc., etc. So it's just like, yeah.
And let's say like the building design, it changes with the evolvement of the project. So if I re-upload the model, does like classification from scratch, or it knows previous classification?
Right now we build a scenario where it will basically stay on the elements which didn't change, and it will just relaunch classification on elements on a difference. Yeah. So yeah. But again, we're adjusting it, and this is something we removed from our website because we worked on this product with a few big companies, and we can kind of refining it, and it's a long process. And to build such a very sophisticated and complex product, sometimes it's even faster to build it rather than to implement it in a few companies. So it's everybody who wants to build a product, I mean, it's obvious, but still it's needed to be, to be considered, right? So go ahead.
I must admit, like the UI UX like look great, like the whole experience of the product development.
I wouldn't say that, but yeah, thank you.
Come on. You did like, it's a complex problem, and you did like a great job in like presenting it.
Yeah. Okay.
And I just realized we have at least two things in common, like an structural engineer and having a tattoo on the right hand. Oh man.
What's that?
My tattoo is about like Himalayas and like travel and buildings.
Okay. Interesting.
Yeah. What about yours?
I have a lot about my building concepts. Yeah, I'm joking. It's not about building concepts.
Oh man, you are funny. I think like that's a great way to end the interview. It was an amazing conversation. I learned a lot.
Thank you guys. Yeah, it was a good.
Yeah.
Okay.
Good luck with your product development. Thank you, Maxim,